So for number 3, let's do the average rate of change of G on the interval 1 to 3. Okay, good. Improvement. Always trying to make things better. But let's be honest, if I hadn't had that other little projector to start the year, I don't know what we would have done for the first month. Because if I couldn't have projected anything, I don't know how I would have taught you guys. So, all right. Average rate of change just means slope. It's the slope between those 2 points. So we need a point for 1 and a point for 3. And all you have to be able to do is get those numbers from the chart. So it says for function g, so we want to look at the g column for 1 and for 3. So g of 1 is 27, and g of 3 is 34. So there's no like math basically to get those numbers. You just look at the chart. And then again, average rate of change just means slope. So set up your slope. It'll be 34 minus 27 over 3 minus 1. And you do not have to simplify that or evaluate it. In fact, you're better off not, because it takes time. And if you mess it up, then it'll be wrong. So just stop and leave it alone. And I know that bothers everybody in the beginning, but trust me, you'll get used to it by the end of this class, and you'll just be real grateful that you don't have to do that work. All right, let's write a tangent line to function f at x equals 2. So to write an equation of a tangent line, you need 2 things. You need a point and you need a slope. And our point of tangency is going to be 2. And that was given. I just wrote that in the problem. So for the point, we want 2 and then f of 2. So here's the f column. F of 2 is -3. And then the slope comes from the derivative. So that's going to be f prime of 2. So here's the f prime column. F prime of 2 is 9. So here's your point, here's your slope. If you put that together into an equation, you will have y plus 3 equals 9 x minus 2. So again, I love these chart problems. I think this is great because all your numbers that you need are right there. We'll do one more. So this says approximate g of 0.9. So where should we write our equation? Like where should be our point of tangency if we want to approximate 0.9? Yeah, good. 1. It's got to be really, really close because we're locally linear. If you get farther away, it's not a good approximation anymore. So we want our equation to be at 1. So we need a point and a slope. We're going to write the equation at 1, and this is function g. So the point is going to be g of 1. So here's the g column. G of 1 is 27. And then slope comes from the derivative. So this will be g prime of 1. And so here is the g prime column. G prime of 1 is -46. So putting that all together into our equation will give us y minus 27 equals -46 parentheses x minus 1. So that's our equation of the tangent line. And then all you have to do for your approximation is plug in 0.9 and then get y by itself. So y is approximately -46 times 0.9 minus 1, and then I've got to add that 27 to the other side so that y is alone. But this is another reason approximations are needed, because when we were doing those questions on the other side of this, we didn't really need to approximate because we had the actual function. But for here, you have to approximate because you don't have values at 0.9. All you have are 1, 2, and 3. So that's why an approximation is necessary. And then let me read the question I just got in the chat. So the reason we picked 1 for our point of tangency is because that's as close to 0.9 as we could get. So that's why we picked 1. And then the reason it was g of 1 is just because it said function g. So when we did g of 1, we got 27. And then the slope came from the derivative. So g prime of 1 was negative 46. And again, we picked 1 because it was really, really close to 0.9.